How's it going? I want you guys to understand that the first half of this chapter and the second half of this chapter are completely different from each other, kind of thing. They're almost two different chapters in one. So I really want you to make sure you have the first four sections of this chapter down. If we were in class right now, I'd probably give you like a mini test over the first four sections before we even started section 5. So it is kind of a little bit of a change of pace, but they still go together fairly well. So make sure you have the first four sections down before you really start into this video. Okay. So section 5 is about what we call polynomials. Okay. The goal today is going to be to classify polynomials and write them in standard form. Okay. So the first thing we want to talk about is the degree of a polynomial. Okay. So the degree of a polynomial, basically what we do is we just simply concentrate on the exponents. We don't really care what the numbers are, or the coefficients, what we call those, in front. All we really are concerned with are the exponents. Okay. So the degree, and basically what we do is we add them together. Okay. So this would be a 4, that would be a 3. This is a 7, the degree would be a 7. Okay. Again, this one, don't care about the 4. We only look at the exponents. This has a degree of 0. Okay. Remember, if you see what looks like no exponents, there's always a little 1 there. We just don't typically write that. So this would be a degree polynomial of 1. This would be a degree polynomial of 2. Now, if you see multiple terms, what we do is we actually look at them individually. Okay, so this first part, the 4x, that would have a degree of 1. This would have a degree of 5. Okay, and then what we do is we pick the bigger of the two. Okay, so this would be a degree of 5. Very simple to find the degree of a polynomial. Okay, and that's going to come into play a little bit later, but we'll talk more about that in a second. So we have different types of polynomials. Okay, the most basic type is what we call a monomial. Okay, now a monomial, the prefix mono means 1, right? So it basically has one term. The formal definition is a number or a variable of a product of numbers and variables with a whole exponent. So here are some examples. 8 would be a monomial. 4x would be a monomial. 2x to the third would be a monomial. 5x squared minus y to the third. These are all examples of monomials because it's basically one term. Now, some things that are not monomials would be things like 3x to the negative second power, because this has to be a whole number, has to be a positive as well. No decimals, no negatives kind of thing. This would be another example of not a monomial because based on our rules, these are kind of the same thing, right? Because you could rewrite 3x to the negative 2 as 3 over x squared kind of thing. That's our exponent property we learned a couple sections ago. So, those are examples. This has multiple terms because it's separated with a plus or a minus. These are not monomials, okay? This is actually an example that 5x plus y is actually an example of what we call a binomial, okay? Because a binomial, the prefix bi means 2, so it basically has 2 terms. 2x to the third, or 2x squared plus 3x, that has 2 terms. And we separate those with a plus or a minus. X plus 3, 2x plus 4y. These are all examples of what we call binomials. A trinomial, tri is a prefix means 3, so this has 3 terms. 5x squared plus 2x minus 3, 7x squared plus 2x plus 9. Those are all examples of trinomials. Poly, prefix poly means many, is what we would call basically all of these are polynomials. Okay, technically any of these, a monomial, a binomial, a trinomial, they're all examples of polynomials. But we also can use the term polynomial for 4 terms or more. We're not going to come up with a name for every single number of term, but we have ones for 1, 2, and 3, and then we have an overall polynomial that is the sum of difference of any number of monomials. Yes, a monomial is a polynomial. So is a binomial. So is a trinomial. But we can also use it, if you have 4x to the third plus 3x to the or 4x to the fourth plus 3x to the third or plus 9x squared minus 2x plus 1. Like we have all these terms. We're just going to end up calling that a polynomial. Okay? So we have basically 4 terms. We have monomial, binomial, trinomial, and then we also have polynomial, which would be many. Okay? And then how do you find a degree of a polynomial? Again, we kind of already talked about this. We basically look at these individually. This part would have a degree of 1. This part would have a degree of 5. We pick the bigger one. This is a 5th degree polynomial. Okay? This part, remember if you have multiple things, this is a 2 and a 1. This part has a degree of 3. This part, we have a 1 and a 1. That would be a 2. This, again, we don't care about the number. The question is like how many x's are attached. That's a 0. And then we pick the greatest number of those. So this would be a 3rd degree polynomial. Okay? Very simple so far. So now we have another thing we have to talk about, which is putting polynomials in standard form. When you put things in standard form, it's really as simple as putting the term with the biggest degree first and then working your way down to the smallest. Meaning like this part, the 20x, this would have a degree of 1. This would have a degree of 3. There's no x's on this, that's 0. And this has a degree of 2. So we just put them back in regular order, meaning this term right here, this negative 4x to the 3rd, that actually should come first. The negative x squared, that should come second. The 20x, so plus 20x, that should come third. And then the plus 2, that's the smallest degree. So this would be just a better way of writing that, okay? So when you put things in standard form, that's truly all that means, is to put them back in order of the biggest degree to the smallest degree. That's all that means, okay? But we do have some, going back to some of the vocab, we have some special terms that we have to talk about. We just talked about these. The number of terms. If we have 1 term, then it's a monomial. If we have 2 terms, it's a binomial. If we have 3 terms, it's a trinomial. Remember, technically speaking, we can use polynomial for any number of terms, but we definitely use them for 4 or more, okay? And then we have names based on the degree of the polynomial. If the highest degree is a 0, we just call that a constant. So an example of that would be like this 8, just a number. That's what we call a constant, okay? If you have a degree of 1, we call that linear. An example of that would be something like this right here, this 5x plus y. This has a degree of 1, so that's what we call linear. Or if another example, if you think of it as 4x plus 3, this has a degree of 1, but if you graph that, that's going to be a line. That's why we call that linear, okay? If you have a degree of 2, we call that a quadratic. A degree of 3 is a cubic, degree 4 is a quartic, and a degree 5 is a quintic. 6th or more, we just call it a 6th degree polynomial, 7th degree. We can't come up with names for everything. I'll be honest with you, this one is very rarely used. I would not worry about that one too much. We are definitely going to use linear a lot. We already do. We use quadratic a ton. We're going to do a lot with quadratics in the near future. Cubic is a pretty popular one that we use a lot of. The quartic, not as much. This is starting to get on the realm of not used very often. Quintic is very, very few people even know that word kind of thing. Okay, but we definitely, I would make sure you know constant, linear, quadratic, and cubic for sure. Okay. Now, what that means is if we have these 2 different ways of naming things, we can classify polynomials both by the number of terms they have and the degree. So let me set that aside right here and just come up with a few examples for you, okay? So this 5x minus 6. Well, we can come up with a degree name for it and a number of terms. The degree of this has a degree of 1 and 0. So this has a degree of 1, right? And then it has 2 terms, right? So there's number of terms is 2. So that means it has a degree of 1, which means it's a linear, right? It has 2 terms, so it's a binomial. So we would call this a linear binomial. Okay? This one has a degree, the biggest degree is 2. And it has 1, 2, 3 terms. Okay? So going back to our list, degree of 2 means it's a quadratic. 3 trinomial. So this is a quadratic trinomial. This one, we have a degree of 7, degree of 2, degree 1, right? So this has a degree of 7. And it has 1, 2, 3, 4 terms. Well, we don't have a name for the 7th degree, so we just call that a 7th degree. We also don't have a special name for 4 or more terms, so we're just going to call that a polynomial. So we would just call that a 7th degree polynomial. And that really is all that is. So here's the things you really need to know out of this section here. You need to know your names. Okay, you need to know what a monomial is, binomial, trinomial, kind of thing. Definitely start learning these terms of what does it mean to be linear? It just has a degree of 1. Like what do these look like? Come up with some examples. Putting things back in order, but I didn't do a whole lot of examples of those because putting things in standard form is very, very simple to do. Just all you're doing is listing them back from biggest to smallest. That's really all that is. Okay. Try a few problems out of the book, out of Khan Academy, and let me know how it goes. So I will talk to you guys later.